to this and decarbonization by Dr. P. Paul Navan. He is working in a School of Petroleum Technology from Pandit Deendayal Petroleum University from Gandhinagar, Gujarat. Okay, so it is very honor. I'm going to invite for today's resource person from our department and our HOD sir. Okay, thank you so much, Paul Navin. Over to Haripriya.
A very good evening, one and all. Today, we all are gathered here for a contentful webinar on future net zero energy system, hydrogen, CCUS, and decarbonization. So, a heart welcome, one and all, for this valuable webinar. To address this gathering and to brief us this topic, we have our chief guest, Dr. Paul Navin sir from the School of Petroleum and Technology, Pandit Deendayal Engineering University, Gandhinagar. Let me read out his profile to make you understand how important this session is. So, Sir is an experienced PhD researcher with demonstrated background knowledge on unconventional resources, reservoir engineering, and technology. Um, Sir has special expertise in the following areas like sorption kinetics and diffusivity studies, pulse decay analysis, fractal analysis, pore scale modeling, machine learning and artificial intelligence, reservoir modeling, and simulation. Some examples of Sir's leadership qualities are like he is a research coordinator for the International Conference PEDJP 2017. He is the department representative for 2 years, 2016 to 2018, and he led the team which conducted field assessment of ONGC's Ankleshwar field and Gandhar field. Some of his awards and achievements are his team is one of the top 3 best teams in GeoQuiz held in 77th EAGE conference and exhibition in 2015 Madrid, Spain. He is the recipient of Young Scientist International Travel Scheme funded by SERP. He is the best contestant in Shutterbug contest, Geo Conference 2015 IIT Dhanbad, India. So, welcome, sir. A hearty welcome to you, sir, and over to you, sir.
Thank you for your introduction, Haripriya, and I take this opportunity. I equally feel humbled and privileged to be amongst you. Though couldn't come in a physical way, but this virtual mode has created a wonderful platform for each one of us to have a conversation like this on a Google Meet. I welcome you all this afternoon. Amid this escalating transition period of corona epidemic, I feel everyone are doing well and making yourself a safe stay and ensuring your good health. Especially, I take this opportunity to thank my heartfelt feelings to my friend Dr. Raju, and also uh, uh, mechanical department HOD sir for granting me this opportunity to come and talk before you on this topic that is more fascinating to me and for our future generations as well. That is on future net zero transition, hydrogen, CCUS, and decarbonization. So, am I am I okay to share the slides
Yes,
now?
yes, sir. Yes, Paul. Yes, Paul.
Yes,
Just you can
thank you.
share your PPT. Okay. Just I'm
Thank
going
you,
to
sir.
exit. Okay.
Thank you, sir. Thank you.
Okay, Paul. Press
May
it
I
is F5.
know?
F5.
Like,
F5. Paul.
okay.
Make it full size. Make it full size. Make it a
Uh,
presentation mode.
Okay. I have already made it as a full screen
Yes,
mode.
yes, okay.
Is it
Just to
visible now?
move to next slide. Move to next slide. Okay. Move to
Okay.
next slide, Paul.
Just a minute.
Then only I have to know whether it is full size or
Okay.
normal size.
I'll just check it out. Just a moment, sir. I'm just sharing
Okay,
my
okay, okay.
screen.
No problem, no problem. No problem. Dear student, please stay up to last minute. Why? Because of today resource person will explain along with this what are the benefits of internships, how we're going to get the job in core companies, how we're going to get some industrial tools like that. He will explain very clearly. Why? Because of he is working in R&D in that college, so definitely he's having much more experience regarding how to get campus recruitment and also how to get some good facilities in any other college, how to get MS in foreign countries. We also explain last 30 to 40 minutes. So please stay up to last minute. You have to get some knowledge regarding code and also regarding your placements and everything. Okay, thank you. All I mean,
Uh,
okay.
so right now, is it in a full screen mode?
Okay, good, good, good. Please carry it, please.
Just check it out. Is it okay?
Okay, good, good, nice, nice, and good, good,
Okay.
good. Please continue.
Thank you once again, Rajesh sir and HOD sir for granting me this opportunity. And myself, Dr. Paul Navinso. I'm currently rendering my services as assistant professor faculty in the University Gandhinagar, Gujarat. Um, in this in this afternoon hours, I know that it is quite heavy for each one of us to come before and to listen for a 1.5 hour lecture like this. But I just understand the situation, and I assure you that the subject is going to be one of the fascinating subjects for each one of us because our future is completely depends on our well-being and our progress towards the economy of our country. So, as an engineer, how we are rendering our services, how we are coping up with the day-to-day situations of our life, and how we are giving our contributions in terms of research, in terms of the knowledge which we acquire in our research, in our engineering field, and in our whatever studies we do. So that is going to help not only our professional life, also the country to progress towards one of the wonderful place where we can see the sustainability in energy and all the other resources which we have today. Okay, further moving on, I'll just put the paint on what the topic is that future net zero energy system as we transit towards the energy sustainability that few of the new upcoming energy resources like hydrogen, carbon capture, utilization, storage, and decarbonization. How we look into each one of this, I will be painting out all these things as we progress towards the end of the slides. So, what is net zero scenario is exactly about? It's an ambitious scenario designed to explain whether the resources which we have currently can be exploited or else we can able to like in a full-fledged way on an optimized way with the available technology today, whether we can be able to get it done. That is what the major thing is about. And how can we, as we see that today due to this rapid industrialization and too many of cement factories, chemical industries, rapid growth in the utilization of automobiles, we see that a lot of greenhouse effect forming in the atmosphere. To a certain level, the gases which are emitted towards the atmosphere are fine, like carbon dioxide, carbon monoxide, methane. But in a larger extent, this greenhouse effect becomes a huge problem, causing a green global warming. So that is a huge problem. So the main issue is with the carbon dioxide content in the atmosphere. So we have to find out such a solution where we can use this carbon dioxide, or how to reduce our usage so that we can reduce the amount of carbon dioxide in the atmosphere, or else whatever carbon dioxide is already there in the atmosphere, how can we use it in a better way so that we can come out of this problem called global warming. So this particular net zero scenario, what it really means is that the amount of carbon dioxide we release into the atmosphere and the amount that we are able to utilize is like how we are able to capture it through the forest, through the any other elements which we have with us. So whatever we release the carbon dioxide in the atmosphere, it has to be equally absorbed, equally have to be balanced so that that net amount in the atmosphere remains very balanced. So net zero is something that the amount of carbon dioxide released into the atmosphere and the amount of carbon dioxide utilized or else being absorbed, it should be equal. Then it becomes a net zero. So as of now, what we see is the global warming effect is because of the positive aspect of the carbon dioxide. The amount of carbon dioxide is more than that we have it have its absorbance over the surface of Earth or else beneath the surface of Earth. Because of this content, it's not net zero phenomena, but we have to move our technology in such a way that in such a strategical way that we have to hit this called net zero effect so that we can have a balanced effect of the carbon dioxide which that will be released into the atmosphere, also the amount of carbon dioxide that will be utilized and it can be absorbed on our surface, so that our climatic conditions remain the same and our climatic conditions won't be disturbed much. So this net zero phenomena highlight the areas whether we do have a choices for decarbonization. Decarbonization is that reducing the carbon content rate in the atmosphere. So, and to examine the levels, how we can, like in a way, how can we progress with the technology or else with any other standards so that we can move towards the progression of this net zero. So, roughly many of the countries in the world on a global view, they have put a sketch line, they have put a pathway until the year 2050, because they want until 2050 they want to see the reduction in this amount of global warming gases like greenhouse effects on the atmosphere, so that we can it's a 30-year period of time to have they have all come together and lay down a path so that by that time they could get reduction of this global house effect or its global warming effect by then. So the assumption are that in a global aspect, many countries like Norway, UK, and all other developed countries, like Scandinavian countries, they're all moving towards it. Like what about us? Like as we are in India, how we are progressing towards it? So what steps we can take so that we can create this net zero effect, like other countries are doing, so that we can also do that by the end of 2050 as we move down the pathway of 2050 down the line. So the assumption is that India would like to contain to sustain rapid economic growth, because as we do this, it also creates economic growth for our country equally. So with the compound annual growth rate of 5.4 percentage from 2015 to 2050. So moving forward, what the complete the top team talk about is that energy is at the heart of economic development. That's why we always have to seek into the sector, that is energy sector. Energy is the heart of economic development, and perhaps no other country is more challenged by that association than India, as it strives to create a better life for its population. We know that our population is almost 1.4 billion now. So how can India can accomplish this, and how can we make progress towards reaching this net zero emissions by the year 2050? Like we have to check that in support of broader well-being. Further moving towards the slide, I will be sorting out all the things like what technologies are available and what technology is more like helpful for our country to adapt that and to can move towards this net zero effect. Coming to this slide about the modeling approach, widely used modeling approach is called Markov modeling approach. Because what Markov modeling approach, what it does, like it delineates the choices, like it sees how many options are available, then it will try to delineate the options and will suggest us the least cost of the economy. It's an integrated energy systems modeling framework that's used to guide like in regard to policy formation of the government and investment practices uh, within the country or else within a global aspect in a very comprehensive way. So it is a widely used technology, a widely used technique of modeling this, taking all the choices into consideration. It's a widely used, it's very well proven, and it's been continually a lot of evaluation is also been taking place in this framework for accessing this wide range of energy, economic, environmental planning and policy issues. So, like what our Indian government, there is a particular set of Indian government that we also try to use this market modeling framework to see that how many available choices are there in energy sector, so that we can optimize the amount, so that we can move towards our strategy to the net zero by 2050. So, like to check that how many possible fuels are available to us, how many technological choices there are there for us, and also to have an understanding about the parameters or constants that will like possibly equals the levels of fuels available and technological uptake over a period of time. And a few of the assumptions of this modeling approach is that technological progress always continues, cost reductions with scalability, and also we have to ensure that reliability supporting to the infrastructure, and a lot of aggressive R&D, research and development efforts has to be done so that we can develop such take it in automobile sector, take it in the thermal power plant sector and electricity. We have to go towards this carbon neutral fuels, or else carbon neutral steps. So it has to be an equal collaborative approach by the government, for the business stakeholders, for the consumers, even the citizens of India like us. So we also are part of this country. So we also have to take necessary steps in adopting few of the things into our day-to-day life, so that we can reduce the carbon dioxide the emissions into the atmosphere, and we try to move towards the carbon neutral fuels and carbon neutral utilization. So moving again towards the towards the strategy, that what are all the things we can visualize down the line in 2050 is that we can completely shift towards most efficient and use devices, devices which are of low carbon dioxide emission emitters. And we also can use this maximize the end use electrification, like electrification products which we use in our day-to-day life. We are more into things we use in our day-to-day life are completely electronic devices. So there is also, we have to see in an optimized way. Now we can see during the progression of time, earlier there was electric bulbs, then it moved to LCDs. Now we're towards LEDs. Now again it's moving towards further advancements. So there is a continuous optimization in order to ensure that the amount of gases, the amount of greenhouse gases emitted into the atmosphere to be in a very limited way, or else the absorption should be in such a way that the amount of carbon dioxide and the amount of greenhouse gases effect should be absorbed equally, so that it creates a net zero in our environment. So down the line, we can see that technologies are also being upgraded, which moving towards the low carbonized options, like steel sector DRA, direct regular iron that we use. Like it's also moving towards this hydrogen side, and starting from 2030, the steps have been already taking place. A lot of research has been done in this aspect. So there is a larger changes that is going to be taking place in the steel sector. So new IC industries, we know that Tesla and other companies are also coming up with lots of automobiles which run with electricity. So this is also coming into wide range of applications, wide range of adoption in many other countries in order to ensure their support, their contribution towards this climate control. And also we see that no investment down the line in India is not going to happen in coal-based power plants after 2030. So as we move towards this, these are all the steps that can be witnessed. Uh, And coming to this energy challenges, what can be the challenges? Still, though we are moving towards this, what are the still challenges? What are the limitations still exist in the era? Is that despite pushing this limits on a residential or residual emissions, still the emissions has to be somewhere around 1.3 billion tons. And this carbon sequestration is one such technology. So what it does is that it takes this atmospheric carbon dioxide. It will try to capture this atmospheric carbon dioxide and then will try to inject that carbon dioxide into the subsurface below our Earth. We have lots of strata, lot of strata of rocks. So we'll try to inject, we try to drill a well into the subsurface. We'll try to inject the amount of carbon dioxide that is contained, that is captured into the subsurface, so that we will permanently seal that into the subsurface. So we completely store that carbon dioxide in the subsurface, so that it won't escape again into the atmosphere. I will be talking more about the CCUS, that is carbon capture and utilization and storage. The sequestration is that which pressurizes, which forces the carbon dioxide that has been captured into the subsurface and will try to hold that carbon dioxide, will try to retain that carbon dioxide within that subsurface strata. And a lot of advancements are like though it has been taking place, like decarbonization has to be in line with agricultural, commercial, residential, and transport sectors. And currently, what the thing we see is also that adequate lack of adequate technological solutions for especially this industry sector. So we have to also do a lot of R&D over this, lot of projects. What we do in our third year or fourth year, we have to concentrate on this technological solutions, how we can provide a technology so that we can have the energies the amount the current energy sector is providing us. We should also increase the energy because demand is more. So we have to increase the amount of energy, and also we have to see that how environmentally, how climatically it is helpful for us. So that is where we have to take care of our projects whenever. So you might, I understand few of us will be through the internships and through the companies, you might be seeing that there is a particular section called HSE, Health, Safety and Environment section. So what that their particular theme does is that they take care of that effluents or else how amount of gases that are evolved in the atmosphere. They take care of that. It shouldn't be more than the government permit. It has to be within that. If it happens, there will be a case on that particular industry, and it will cause lots of problems to the industry. So always there exists a department called Health, Safety and Environment, which takes care of employees' health, safety, and also the complete plants, environmental conditions. So we also, like as we emerging engineers, we have to look forward for this technological solutions in this aspect, like providing technology which can help in mitigating the greenhouse gas effects into the atmosphere and help thereby country to move towards net zero country, net carbon dioxide net zero country. So these are all the few challenges which can be exist even after 2030 or 2050. So come up with some of the key elements to focus on when we move towards this line of net zero effect is that we have to travel to this energy efficiency. The amount of energy, you know that IC engines today, even with a lot of upgradation, still they are moving towards 60-70% of fuel efficiency. But we have to create such an efficient system where we can have upgraded energy efficiency and also electrification. Today, we know that we are a lot more into the electronic devices. In household purposes, we take, in industrial purposes, we take, on a commercial basis, everything is mostly electrified. So electrification should be end users and processors. It should be so optimized so that it won't consume lots of power, and so that the power consumption can be less, and the amount of job it does, it has to be more. And also, we have to move towards this. We have to switch our utilization towards this decarbonized fuels, like take it in electricity, usage of hydrogen, bioenergy. These are some of the key fuels that Indian industry or as Indian energy sector can look forward for the decarbonization, so that we can reduce the carbon dioxide rate in the atmosphere. So I feel so far so you are able to understand, you are able to catch up to the things which I'm explaining. If at all, if you find it any difficulty, any problem, you can you can ask me in between. You can stop me wherever you want, so that we can sort out the things more clearly. Okay. So moving forward, so as like focusing on our country, like whether we are able to held to the parameters or else rules and regulations that global climatic rules are sought for. So there is a Paris Agreement that happened in 2015. I'll talk a little bit about this Paris Agreement. Paris Agreement itself, you have to understand it is about climatic change. So in this Paris Agreement, what happened is that almost 195 nations, like including India, China, and all other developed countries, are the signatories. They signed this agreement. According to this Paris Agreement, is that we have to reduce the climate uh, 2 degrees less than what we have today. So in other few years, we have to work in such a way that the climate, the weather conditions, the temperature of the global should come down to 2 degrees less, and that is 3.6 Fahrenheit. And there is a tolerance also given that 1.5 degrees we can reach, and still we should not go beyond 2 degrees Celsius as of today's temperature. That is on a global way. So that is what the agreement. So we have to ensure such a technology where that this global warming shouldn't do more and shouldn't increase the temperature beyond 2 degrees Celsius. So over 185 nations have been signing this agreement, and afterwards, two other countries are also joined, like Syria and Nicaragua, which is in Central America. So they have discussed about the possible new ways to mitigate this greenhouse gases in the atmosphere and ensure a proper climatic change. So this agreement is very legally binding, and all the G7 countries, they have ensured that they will be investing like $100 billion into this aspect, so that they can take their part in this climatic change aspects. So this was done during 2015. This is about the Paris Agreement. Even India has signed about it. So now India is also part of this Paris Agreement NDC. NDC is nationally determined contribution. Like each country is contributing. This all this 197 countries are contributing towards this climatic change. That the global temperature shouldn't rise beyond 2 degrees Celsius. And here we see that. Uh, we see the graphs that how the fuel combustion is taking place, how this electric power means down the line there is no rapid growth. We are trying to. India is also taking its steps towards this climatic change control in order to reduce the amount of carbon dioxide that is released into the atmosphere. So in all the ways, in terms take it in carbon emissions, in terms of electric power utilization, like adapting the fossil fuel technology, like fossil fuels that are from the subsurface, like LPG gas, petrol, diesel. All these things are the most prominent things that will cause lots of greenhouse effect in the atmosphere. They release a lot of effluents, like coal thermal power plants. They create a lot of effluents. They release a lot of effluents in the atmosphere. So we have to move towards this non-fuel fossil fuel base, so that so that we can effectively create energy power, electric power, so that using this reducing the usage of this fossil fuels. And also in the another graph, we see that additional carbon sinks, like as I was mentioning, that the amount of carbon dioxide we release into the atmosphere, we also have to have enough sources to absorb it, or else the carbon should be sink somewhere. It has source, it also has to sink, so that the net amount will be balanced. But what is happening is that we were able to create 2.5 to 3 billion tons of carbon dioxide through forest and tree cover by 2030. So a lot of afforestation is taking place, and we're also moving towards this uh, line of climate change uh, pertaining to this Paris Agreement. So over this 50 years, Indian economic transformations have been remarkable. Until this COVID-19 pandemic struck in early 2020, as we all witnessed this. The country's economic story was defined by strong growth, an increasingly dynamic business environment, rising productivity, and well-documented boom in both tech industry and as well as in other all sorts of industries. In 2019, India has become the fifth largest economy in the world, overtaking UK and France, that we all know uh, by seeing the news. So India is booming, and India's economy is booming. Currently, we are in fifth place in terms of uh, economy. We are the fifth largest economical country in terms of GDP and all aspects. So, how with increasing the GDP and with increasing economy, we also see that the amount of greenhouse gases that is emitted with the supply and demand of the energy, we see that in this graph it depicts about it. So the final energy demand could be more than double as the economy grows at double. And the emissions intensity continues to fall for, and this higher emissions always remains because we see that population is ever growing. We are now 1.4 billion, and still we see that lot of usage of this energy in all other sectors in our daily usage. So it is estimated that in India's per capita, carbon dioxide emissions at 1.8 tons per person in 2050. Each person is emitting 1.8 tons of carbon dioxide into the atmosphere. Just see the intensity of carbon dioxide we are emitting. And we stand in ninth position in terms of this. Like in USA and other parts, like USA is almost like 4.8 tons per person, but India is around 1.8 times. So, but still, it's high because taking the population into consideration, our consumption is almost 25 joules per person. That's very high. So, with ever increasing population, our country has to take enough strategies, enough steps towards this decarbonization and net zero emissions. So there is a thrust on us, on each one of us, as we study our engineering, or we go through this technology. A lot of thrust is on us, so that we have to adapt a technology. We have to give some solutions, technical solutions, where we can help the industry, or else help the automobile industry, a technology that can mitigate the amount of greenhouse gases emissions into the atmosphere, and also can enhance the energy demand, so that energy so that we can meet our demands. So moving further, I'll be talking we understand that India is a vibrant economy now, standing in the fifth place. Coming to this slide, where we see that demand of materials put us on pressure on emissions. Here we can see the compared to other countries, where we India stand is at this plus point. We are estimated around. We are here standing here with the usage of this iron. Iron today, there are about 3 billion tons of steel in use within our country. Take it in buildings, in the construction of cars, in manufacturing industries, in appliances, and pipelines, industrial plants. Everywhere we are almost using like 3 billion tons of tons, and we know that with increasing population, this consumption will again increases. So this increase in infrastructure and construction manufacture goods in cities, we can see that ever-growing cities like Bangalore, Hyderabad, Delhi, lots of this construction work is going on. We are using lots of amount of steel into day-to-day our lives. And this meeting this few steel needs in India alone could add 24 billion tons of carbon dioxide into the atmosphere. See the intensity, how much carbon dioxide we're releasing into the atmosphere because of this, because of our usage in our day-to-day life activities. So we are, as citizens, we have to be partakers of the government in giving our own contribution in taking part of this net zero effect, and helping the government in all the aspects. So, and looking forward for the other slides, now we see that there is a lot of pressure on us as we see the amount of emissions that is being released into the atmosphere. So, how can we implement this? We see that there is some strategy in our day-to-day life. We are emitting like 1.8 ton of carbon dioxide every year into the atmosphere, each person of us. So what has to be changed? What has to be changed so that we will be stepping towards this net zero emissions, and how we have to take a progress towards it. So that is the main theme of this particular topic, the future net zero energy system using hydrogen, this other techniques, which are alternatives for our regular usage, so that if we adopt them, we will be able to give our own part in this net zero emission along with the government rules and business strategies of India. In a global view, we will be able to contribute our hand in this Paris Agreement that our temperatures shouldn't go beyond 2 degrees Celsius within another few years. So in this aspect, we see that what needs to change. One thing primarily we see that electrification and our primary renewable, we have to shift towards this renewable sources so that we can, nowadays we are depending more on a coal-based thermal power plants. We have to shift to the other sectors. So we have to equally move because we see the demand. We also have to shift our paths towards other things, and also you develop some low carbon energy supply. These are all the few aspects as we do our interns, as we do our projects. We have to take care of this. These strategies have to be changed. We have to go towards improved energy and material efficiency and low carbon solutions we have to provide. And geological storage, that's what I was mentioning about carbon dioxide sequestration. We call that we capture the carbon dioxide and sequester it into the beneath the earth surface so that the carbon dioxide will try to retain in the subsurface and will be stored for a long time. They are also called as natural sinks. So these are the progresses that have to be taken place so that we can redirect our country's economy. We can size new business opportunity, and also we can have a negative transition impacts, and we can drive our economy to wider change for a orderly transition. So it shouldn't be a very jumbled transition, but an orderly transition. So this has to be a collective work of every society person as we see in our society today. So that only can help us to move towards this net zero emissions energy system uh, by the year 2050. As government is taking steps, we as our citizens, we also have to give our equal contribution in taking our own contribution in this way. So looking forward for the fundamental changes in how we have to use our energy. So in, in early action, as early as possible in our infrastructure, in our day-to-day life, we have to accelerate towards the clean technologies, like significantly use low carbon electrification, and also create some other economy that's hydrogen as an important fuel in our day-to-day life activities, and also transform to biomass use. Also, we can now take steps towards supportive, energy efficient, and low carbon choices. We can take this choice as also, we can adapt this choice also in our day-to-day life so that we can improve the energy and material efficiency and use carbon pricing to drive change throughout the market. And mainly stick onto this unavoidable emissions, like use unavoidable emissions into the atmosphere. Don't need to adapt such things which releases a lot of carbon dioxide into the atmosphere. So that alternatively we can go for these things like carbon capture, utilization, storage, and use this natural sense to sequester the amount of carbon dioxide in the atmosphere to the subsurface, and they can be retained for a longer time. So I'll be talking about each of these things, how we can implement in our day-to-day life, and how the technology is moving towards this to give the energy security. Let's see that we require more and more cleaner electricity, as we see that each energy sectors is seen here from 22 to 2000 to 2050. With ever increasing population, the power generation has to also increase to meet demands. We know that our usage into electronic devices have increased a lot, and we are more towards this line. So opportunity for electrification in every sector of the economy. And power sector is about to grow more than 4 times in another 30 years. That is what projected in another 30 years from 2020 to 2050. And 90% of power generation is from renewables. Like when we shift towards this transition, we can see that 90% of power generation can be from renewables, dominated by wind and solar. And regional power grid connectivity, grid scale electricity is very critical in this aspect. So renewables deployment on the scale is very much needed on all other renewables. So we see that with increase in population, the increase in like a population explosion, we also have to take care of our energy demand, moving towards more towards the cleaner electricity. That's one step which every sector is to moving towards. We understand that recently Elon Musk, Tesla's have sanctioned a huge bulk of amount for projects on carbon emission, those who work on this carbon mitigations. So a lot more industries like take Apple, Microsoft, many other countries are also moving towards this line where they can contribute their level so that they can reduce the amount of carbon dioxide that will be released into the atmosphere so that we can stand to the agreement that was signed in Paris in 2015 that the temperatures of the globe shouldn't reach more than 2 degrees Celsius. So we know that energy sector is going to increase. And also you can see this graph that we can adapt a hydrogen economy. So down the line, hydrogen can be used as an alternative fuel, other than the fuels which are using today. Like hydrogen fueled vehicles, hydrogen fueled vehicles. In 2040, it is like expected that like 3 million hydrogen medium heavy fire trucks can be on the road, can be used on the roads by 2050. So much of progression is taking place towards this hydrogen economy, adopting hydrogen as an alternative fuel. The 13% of hydrogen can be used as a final energy. So that is what steps that have been taking place even by industry and transport sector. So it is expected that by 2040, blue thing you can see that is hydrogen, and the black thing is about hydrogen industry. So in 2040, even our usage of hydrogen may exceed the natural gas usage. That's a good point. So that is why we can move towards this move towards the sustainable of energy demand. We can use something which uses less energy consumption than the other fuels which are using in order to live. Other aspect is that technology and nature to remove remaining emissions. So there is already lots of carbon dioxide in the atmosphere. We see that amount of carbon dioxide that is there in the atmosphere. In 2020, you can see the increase, and other than until it goes until 2025, we see large amount of carbon dioxide emitted in the atmosphere. That is the reason, sole reason for temperature rises in our weather condition in a day to day, year to year. We see that there is a change in temperature rising. So the carbon capture, utilization, and storage is essential for both the industrial purposes and every way, so that we can directly capture this carbon dioxide from the atmosphere and can store this carbon dioxide in our subsurfaces. So until now, like it is estimated that 400 million tons of carbon dioxide can be captured and stored by this technology. Why especially we have to go for this technology is that we see that in the third point, natural sinks like forests, plants, and all other carbon dioxide absorbers that are there in our environment. They can only remove 0.9 gigatons of carbon dioxide every year. But what it demands is that we require additional 30 to 40 million hectares of additional forest area in order to absorb or else to be used as a natural sink for this carbon dioxide. It's very huge. That's almost equivalent to our Indian state, Rajasthan. Such a big area we need of forest area. Just imagine. In Rajasthan is currently is the largest state in terms of area. Such a large area of forest we need in order to mitigate, in order to add that as a sink for the carbon dioxide that is in the atmosphere. So can we implement this on our subsurface? So that is why carbon dioxide utilization and storage. We store this into the subsurface because subsurface creates such an environment, such a condition where that more carbon dioxide can be stored within the subsurface than on the surface like forests. So that is why the lots of technology, lot of quest is moving towards this technology that is called CCS, carbon capture storage, or else carbon capture utilization and storage. So I'll be talking more about this carbon capture utilization storage, because how important is this, so that we not only mitigating the amount of carbon dioxide in the atmosphere, but also storing it in the subsurface, and not only just storing the carbon dioxide in the subsurface, also utilizing that carbon dioxide in the subsurface to push our natural resources. For example, we're having a gas inside the subsurface, or else we take petrol inside the natural reservoirs which are in the subsurface. We can can force that natural resources, and we can get an enhanced production. So, for example, today our Indian production is 30 million tons of petrol every day. So that can also be enhanced so that we can meet our energy demand. We know that India is a huge importer of crude oil, heavy importer of crude oil. So once we generate our own fuel, once we are moving towards our renewable fuel, our country can be a independent country in terms of this fuel dependence. It won't need to depend on the Middle East countries for the crude. It no need to depend on other countries for energy so that we can meet our demand. So we can be our self-sufficient country by generating our own energy resources by becoming ourselves self-reliant in this sector. So that's one aspect. Um, Changes in how energy is produced is that, as I was talking, in 2050, we see that a lot of renewables will come into play, like wind and solar will dominate in 2050, like more than 65% of our primary energy mix. And nuclear also forms 40% of our energy generation mix. And oil and natural gas still they'll be there, but emissions will be balanced by using this carbon capture utilization and storage technique, or else nature things like forest. And coal usage will drastically come down, and it is expected that no industry will continue to invest in this after 2050. That is what strategies we are moving towards 2050. Moving towards this India's energy transition from 2020 to 2015, we can see that the final energy usage, the carbon emissions, we see that yellow line, how it is coming down the line. So we are also doing our best by adopting these sorts of technologies, these sorts of things in day-to-day life, which not only decarbonize but also release less carbon dioxide into the atmosphere. By using all these things in our day-to-day life and also giving our own contribution, so we will be definitely achieving the target which is in front of us by 2050. We will be helpful uh, in using all these other sources like hydrogen economy, or else this technique called carbon capture utilization storage, or else decarbonifying elements in our total life. So that by by using all these things, we're definitely moving towards this net zero effect, net zero transition in our energy. So moving forward, we can see that the problem currently is that natural sources releases carbon dioxide. Lots of carbon emissions are like industries, vehicles, and but the carbon absorbents we see in the center. There are the forests, there are plants, they absorb this. So as we see that it requires additional large amount of carbon sink. So technology is that carbon capture technology. We capture the carbon type capture technology in the right you can see, and we inject that into the subsurface. That is called. So the problem is that human activities such as for human activities like we call as anthropogenic effects. So we use this fossil fuels, the natural gas, or else, petrol, diesel, all other natural resources, derivatives of fossil fuel, and we release additional carbon dioxide into the atmosphere, creating a carbon economy. The proper solution can be this carbon capture and storage technology. We can directly remove that carbon dioxide from the atmosphere and can we store it into the subsurface, and we can retain it for permanently for a longer times. And then also not only just storing it, and also we can create a force or pressure to the existing fossil fuel there so that we can meet our energy dependence, we can self-reliant country in terms of our energy sector. So I will just move on this more important aspect that is carbon capture and storage, how relevant it is for us in this area. It's a small video that will talk more about this.
All sound is not came, Paul. Sorry for disturbance, Paul.
Yes,
Sound
sir.
is not.
Sound, okay, sir.
I think it is in mute.
I'll try. Sorry, I don't see an option right
Okay,
now.
okay, no problem.
Yeah, I will be, however, talking about it, so we can have a view.
Okay, okay, you can play.
So I'm sorry for the inconvenience that audio was not properly adjusted, but what it means is that this carbon dioxide utilization storage, we can be able to capture the amount of carbon dioxide and can utilize this for our necessities. So it is said that 20 by 2040, like 300 billion cars, if 300 billion cars are releasing how much of carbon dioxide, that much amount of carbon dioxide can be captured, that much of amount of carbon dioxide can be utilized and can be stored deep into the subsurface. That is what we can see in the right side, that in the carbon dioxide not only capturing it, we are just transporting it into the deep subsurface beneath the surface of the earth. So this carbon capture and storage technology is an integrated suite of technologies that can prevent large quantity of greenhouse gas carbon dioxide from released into the atmosphere. And capture, which involves the separation of carbon dioxide from other gases in the atmosphere, it can be usually adopted at industrial scale, like at the cement plants or thermal power plants, or else various industries. Wherever the effluents are going to the atmosphere, this capture technology is adopted there so that the carbon will turn into other solvent and can be used for other purposes. The storage thing that which I was talking about is like carbon dioxide is injected into deep underground rock formations and often deep even a kilometer more, so that they can be permanently stored and never can be disturbed further into our future. So let's see that what all the capturing technologies currently widely used. This Julia Dunlop is one such pilot project which is currently operational in Norway. So they're trying to use this pre-combustion technology. So there are three available technologies there to directly capture this carbon dioxide from the atmosphere at the power, or like to the power sector, like pre-combustion technology, post-combustion technology, oxyfuel technology. These are all the technologies. I won't be talking much about them because each of them are like the content of themselves. They're such a huge topics. So that here we have a capturing technology which directly takes carbon dioxide from the atmosphere. It grabs all the carbon dioxide and takes it to the storage tank. So now carbon dioxide, we know that gas is compressible. So we can capture as much as carbon dioxide from the atmosphere and it can be stored for some time in the storage tanks. But as long as we capture, we have to deposit somewhere. So we have to sequestrate somewhere. So that is where the viable technologies are there. That carbon dioxide can be stored securely in the deep underground geological formations. It can be used as a value-added commodity. I'll tell you why the carbon dioxide utilization can be considered as a value-added commodity. And also, in the third point, we can see that it can be converted into a biomass, like through algae farming using this carbon dioxide as a feedstock. Uh, this harvested algae are not only like just farming them, we can this harvestation can be processed as a biofuels for non-biological carbon sources. That's how we can also find an alternative to use this carbon dioxide that is being collected from industries. So, and also we see that storage in the deep surface, there are possible options In deep subsurface also we have four options like saline aquifers. Saline formations are water formations with salt water, which cannot be used for our daily purposes. So that's already a wastage, like we don't use it further. So such waters, wherever such waters are found in the subsurface, they're always spread across vast amounts of areas, like large amount of acres. So this carbon dioxide can be stored in such saline formations. And also it can be injected into some coal mines. So in the second option is that coal mines. So it can be, we know that India is in fourth position today in terms of coal resources. So large amount of coal we have. So coal or coal pits which are unminable, means which cannot be mined by using this current technology. So they are very deep inside the earth, which cannot be mined. So that sorts of formations, we call this rock layers as formations. So that also can be used for storing this carbon dioxide. And also this carbon dioxide can be used to pressurize the oil, which is already there. So that whatever oil, we know that most of the formation doesn't produce in an efficient way. They only produce 20% of oil from, if there is 100% content in the oil, we only get 20% from the rock. If we're able to inject this carbon dioxide and we're able to pressurize that carbon dioxide into the subsurface, we can enhance that 20% to 67%, 80%, or like that. Such a huge change in enhancement will be taking place when we inject this carbon dioxide. And also we can see that most of the oil and gas formations, like which we take oil out of it, now the oil, that particular zone is completely waste. It's not of no use. So we can use that depleted oil and gas zones for storing this carbon dioxide, so that this carbon dioxide can be permanently stored and can be used as a permanent sink for this carbon dioxide, so that we never get disturbed with this carbon dioxide into the atmosphere, causing us a global warming effect. So looking further, like how it is used as an recovery, or like how we recover the additional oil. So in one side we see that the production well will be there, which takes out the oil from the bottom hole. So now we drill another well into that same zone and we inject this highly pressurized carbon dioxide. This pressures the oil which is there, which creates a visible zone, which mixes up and pushes all the oil, and we see the additional oil recovery coming from that area. So that is on one way. A lot of research is taking place in this area as well, so that we can take large amount of petrol or diesel from subsurface and you can use it for our daily purposes. Other thing is that unminable coals, where we cannot mine that coal using the mining technology which we have today. They're so deep that greater than 1 kilometer, which cannot go into the mining. So that sorts of coals are also can be used as a target to trap this carbon dioxide inside that. Because coal is itself is a fossil fuel, it's a carbon material, hydrocarbon material. So when we inject this carbon dioxide, it has some affinity. It holds the carbon dioxide very tightly, because gas molecule will try to absorb on the surfaces of this coal. They have such a huge affinity among themselves. They have a variable force of attraction between them. So this gas, like since it's a compressible gas, we can compress as much as gas possible inside this spaces of rock, so that they can be trapped within there for a longer time. So looking forward, like the status of this project, carbon capture utilization in a global way, almost three successful projects are already there. Still, it's an adopted technology. As of today, the world's first large-scale CCS project is in October 2014, which was started at Boundary Dam Power Station in Canada, and also Texas have also implemented this two additional large-scale projects. Which are currently very successful. They're giving a very good results, like mitigating large amounts of carbon dioxide into the subsurface. And also in Norway, like were able to store 20 million tons of carbon dioxide. That's a huge amount of carbon dioxide in a saline formation. Saline formation, as I was telling you, in an ocean, there is some of the zones where salt water is present, which is not at all for use. So in that areas, in the zones, you can directly inject, and that is how they were able to inject 20 million tons of carbon dioxide, which is a permanent retirement in the subsurface. And also in the US and other Canada and other places also, this has been highly successful. Currently in 2020, last year's statistics show that 43 large-scale facilities are still under progress, 18 under commercial operation, 500 under construction, 20 in various stages of development. Once this technology is created, you can understand that we can straight away moving towards this net zero emission tech. That strategy which we are moving towards net zero emission. So as US is a primitive one, which they have adapted it in the early stages in 2014. So how much they were able to inject is that 60 million tons of carbon dioxide they were able to inject every year, and they are utilizing it to draw the oil from the to draw the crude oil from the subsurface. And almost 20% of carbon dioxide is anthropogenic, which is because of our human activities, because of the vehicle uses, because of the uh, because of the devices which uses in our day-to-day life that emits carbon dioxide, like ACs, refrigerator, whatever we call it, as that emits carbon dioxide into the atmosphere. And as I was telling this is a value-added commodity. What it does mean that government has sanctioned a carbon credit. Like as of now, if you use this 1 ton of carbon dioxide for enhanced oil recovery purposes, they gives us $35 for every ton. So that is how government is also providing you fund for this. And if you use it as a direct usage, this the right side one all shows the direct uses for construction materials, for fuels, chemicals, engineering materials, polymers, agricultural products, and fertilizers, like whatever it is, graphene, carbon ceramics. In all this uses, if you directly uses carbon dioxide, you utilize this. So $50 per ton is provided. So much credit is being provided from the global aspect. So for this is an investment. So as of today, we see that 2 to 8 gigatons of carbon dioxide every year is being utilized in this way, and other amount of carbon dioxide is directly injected into the subsurface. So in India, like today, we see that India stands in the fourth position in terms of coal mines or unminable coal reservoirs. So in each state, I show the statistics that how much of area is there for coal reservoirs. So we no need to have a larger forest area. It takes lot amount of time because we require a land area of almost equivalent to Rajasthan. Such a huge land area of forest we require so that we can capture all that carbon dioxide. If you use this available coal mines which are in India, we will be able to move towards net emission. Like we will be completely absorbing all the carbon dioxide that we release into the atmosphere. As we know that 1.8 billion, 1.8 tons of carbon dioxide every person releases into the atmosphere. All this carbon dioxide can be stored in the subsurface and can be retained for a longer time. So the government has identified around 26,000 square feet of area. That's CBM is called coal bed methane area. So under the subsurface, which can be directly used as a permanent storage for this carbon dioxide. So deploying this technology in India, what advantages are there is that as of today, research have been tremendously progressing. So as even my research area is about this. So where we check about how much of carbon dioxide can be injected into the subsurface, how much oil we can get out of it. Since I'm a petroleum engineer, so we deal about those things, how we can derive more amount of energy so that we can meet our energy demand and we can emerge as a self-reliant country. So flow physics are well understood, and capacity estimates are quite positive because we see like large amount of areas are available for retaining this carbon dioxide and the subsurface. This appear to be manageable. So expected that 10 more than 10 gigatons carbon dioxide every year in another 30-40 years can be difficult. It's not that difficult to meet, and we can directly meet that. So it's all about my presentation about net zero energy system adapting hydrogen technology or else carbon capture utilization and decarbonization things in agriculture. Thank you for all your patient hearing. Thank you so much. If there are
Thank you, Paul. Thank you so much for the wonderful, nice explanation regarding decarbonization and how we are going to optimize and what are the distributed methods we are going to use. Okay, I think it is one of the some wide topic. I think so. Okay, thank you so much. Over to our HOD sir. HOD sir. Over to our HOD sir. Sorry, there or not? Paul, you can explain regarding what are the research activities for students, how the students will get internships, or what are the placements? Huh? Shall we explain?
Yes, sir. I can
Yes.
briefly, on a brief note, I can tell you a few things.
Okay.
So, since I assume that most of our friends who are present here are from second year or third year, so
Yes.
and few of them are from final year as well. So, main important thing as I was talking today is about net zero emissions. So, whatever technology, either if you are interested in automobile industry or thermal power plant industry, our major aim, which we see, which we learn in our engineering, like through technical concepts, through whatever it is, adapt such a project so that project can give a technical solution to reduce the amount of carbon dioxide we release into the atmosphere. The effluent should be less. Take it automobile industry, whatever electronic devices you are bringing out, semiconductors or else any automated devices, whatever you frame it out. Look forward for a solution. Like our contribution should be very significant so that we will be able to reduce the amount of carbon dioxide. So main aspect about internships, all these things, what I want to mention is that you can write a proposal, like it is called a one and a half page proposal. You have to read few of the upcoming technologies, write some proposal to any industry, like take it Ashok Leyland or else Tata. So all these companies are working towards this only. They're trying to reduce the amount of effluents they release into the atmosphere. So and also it should be more energy efficient, more power, less power consumption, and more job it has to do. So you try to write a proposals. Like when you try to write proposals, you just forward it to the certain company, to the certain R&D, like research and development. So maybe there will be a chance that they will definitely accept that. If you they like your idea, they like your intention, they like your contribution at the level of graduation, that at the second year or third year, they will be very impressed. So try to read as much as possible the journals which talks about this kind of upcoming technologies. And important aspect these days is that communicate. Like collect the email IDs of HR department, collect the email IDs of R&D departments. Try putting all this proposal. First and foremost, you make ready of your proposal. Proposal in sense like what you're thinking of, like what solution you're thinking to give to the industry. In order to give a solution, you have to know what it is, right? So you understand your subjects very well. Don't take just the engineering as simple like that. Like go each and every aspect, like learn each concept, like how they really implemented in our practical purposes, so that you can give the solution to industry. Once you give that industry, if you don't know, the future is very magnificent. That is how these Indians who are presently CEOs of very good software companies like Microsoft, Google, that is how they evolved, because they were able to give the solutions to problems that were there. So we know where from mechanical engineering, we know the present industrial sector, how it is moving. They're all moving towards this net zero emissions. They're all moving towards this decarbonization, where the carbon dioxide released into the atmosphere has to be less. So try to write some proposals, read well, and have a thorough understanding of your concepts. So wherever you have a doubts, you try to approach your faculties, meet them, and importantly, as I was telling you, communicate. Like directly send those proposals to R&D department. They may give you an opportunity for internship you take, for placements you take. So many of the colleges nowadays, though their placement is not good, their placement conditions are not good. Still, students are able to hit like a right place by writing a nice proposal, by sharing their ideas which they have for the next. So that's why you be very thorough with this. Like not only have the conceptual background, also know the present day technology, how the technology is moving towards. Okay. So main aspect is that collect email IDs of R&D sections and try writing proposals, sending them. That is how we can get. Even while I was a student of masters, when I was doing masters and when I was doing my PhD, that is how I have written a lot of proposals. I never stopped. I always used to write a proposal at least and used to send them to industry. That is how I was able to get some internships at ONGC and other companies. So I was paid even during my internships. Yeah. Yes, sir.
Student, okay, okay, Paul. Students, if you have any doubt, just you ask. Students, it's time for asking doubts regarding your internships and regarding this decarbonization net zero concept. If you have any doubt, just you ask. So I will give the answer. Please. Students, you can ask any doubt regarding today webinar or how we are going to get internships. Okay, where we have to do, what are the good companies they're going to provide the internships. Just to ask any doubt, he will explain very clearly. Why? Because of he's doing an Danban, is a MSD, is MS. So he's having some experience and he's having some idea regarding all these things. So if any doubt, just to ask. Haripriya,
Sir,
you can ask my any doubt. Haripriya, next to Maruti, Omsi. Omsi, remaining students, first year, second year, third year, final year. Okay, Paul, I think no doubts. Okay.
Okay, sir. Thank you.
One minute. Paul,
Yes,
one minute. Sorry,
yes.
I think Sir is not there. Sure,
Okay.
sir.
Okay, sir.
1 minute. Just you right. Paul, I think
Yeah.
one question is sending in chat box. Sir,
Yes,
is there
yes.
any concepts of using greenhouse gases as
Yeah,
fuels
yeah.
for the automobile?
Yes, I have seen
Yes,
Krishna have asked me this
Omsi
question.
Krishna. Yes.
Oh, yeah. Krishna, like very good question. I can say that. See, methane is one such green gas. We call it as greenhouse gas. So methane is important component of natural gas as well. So the natural gas, LPG gas is of butane, but natural gas is major component is of methane. So methane is already a greenhouse gas which is already used. So there that is in CNG and all we use this methane gas exhaust, which is a major constraint. So it's already been adopted technology. But main thing is that our engine, the one engine which is used for CNG and whatever it is, so it has to be efficient. So that it has to be fuel efficient. Like it has to burn the fuel which we give. For example, methane we give it as a fuel. It has to be burned well. So if the engine is not unable to burn it well, unburned gases they release as effluent and that will create a lot of problems.
Okay, thank you, Paul. If any doubts, ma, please. Any doubts? Otherwise, you can
Hello, sir.
proceed. No, okay. Sir, Chodi sir. Over to Chodi sir.
ఓకే రాజు ఎనీ డౌట్స్
Sir.
అడగ
No, sir,
పిల్లల్ని
no, sir.
అడగండి ఏమైనా డౌట్లు ఉన్నాయంటే
No, sir, no, sir. Aim level, sir.
ఓకే
No, sir.
Ma, the students, any doubts? Please.
Sir.
Any doubts?
348
348. I think Vamsi.
Yes, sir.
Please.
Sir, Paul, sir, you said that the carbon dioxide which was present abundantly on the surface of Earth, it's been moved to under the Earth. I mean, up to you said about 1 kilometer distance, right? If the carbon dioxide is sent below the Earth, is there any? You said that the carbon content which was present inside the Earth will absorb the. Well, there is a vicinity to absorb the carbon dioxide, but still there are chances of getting increasing Earth's temperature under there, right? So it will also affect the outer atmosphere. Is it good reason, sir?
Okay, that's a very good question, Krishna. That's a very good question. I really appreciate the way you are thinking. Yeah, coming to this point, yeah, you say that when we inject it into the subsurface, when we sequester it into the subsurface, it retains there and it will be there for a long time. This surfaces, what happens is that they have this layers, wherever layers we are injecting. For example, I have shown the four probable zones like saline aquifers, saline formations, coal bed, that is coal and other. So what they are covered is that they're on the above and the below. They have a very thick rock. So these rocks doesn't allow any of the gases or any of the fluids to come into the subsurface. They cannot impregnate. They cannot travel. That is why they are always in the subsurface. That is why we see if it is the same case with the gas with the crude oil as well. So if that is the case, crude oil will come into the surface. They come out like that. So that's the case with even natural gas. Natural gas which you get in the subsurface, it's a case. So there is always a seal. There is a seal, huge seal, thick seal, which is always there. That is how we target a zone, which zone we have to inject. That is also a very important aspect. Whenever we want to inject this carbon dioxide into the subsurface, why these four probable options are there is that because these probable options are always have a thick seal above it. So this seal doesn't allow any gas to come over it. So it doesn't allow any temperature variations that can affect our surface. So if it is the case, that will be the case with even crude oil and natural gas, which you have surface, which is within the surface. You understood, Krishna? I think yes.
Yes, sir, I got it.
You got it. Yeah, I appreciate really the way you are thinking. It's really good. I appreciate it.
Okay, Paul, thank you. Sir, HOD, sir, please.
If there is no questions, we will close, Raju.
Okay, sir.
So
Okay,
thanks,
no
thanks, Paul, for your valuable time, sparing valuable time and enlightening us what is future net zero energy systems, hydrogen, CCUS, and decarbonization. Thank you very much.
Sir, thank you so much for giving your time as well and giving me an opportunity to come and talk to you. So I really appreciate this. I'm very heartfelt thanks to Raju sir, who has given me opportunity.
Thank you, Paul. I think yes,
for
yes.
everyone who are present here, thank you for taking your time and coming and this. Thank you so much.
Okay, thank you.
Sir, Paul, sir.
Paul, one more doubt. Paul, one more doubt from
yes,
Krishna.
Sir.
Okay.
Yes, sir.
Sir, I have a doubt regarding H2O to fuel cells, sir. I believe that when I search for it, it says that it was an efficient methodology for obtaining the electricity since it doesn't produce any kind of harmful gases into the atmosphere. So why it's not popular in using the why it's not popular in automobile sector, sir? I mean, somewhere it is being implemented, but
Krishna, are you like talking about hydrogen?
Yes, sir. H2O to fuel cell.
Okay. Hydrogen. See today, hydrogen cells like it's still it's under the progression. This research is still in the progression. So lots of steps are taking place in this area because they identified as a hydrogen can be used as an alternate fuel. Because our primary motive is to reduce the net amount of carbon dioxide. So though it's quite expensive as of today, the technology which we have to use this hydrogen as a fuel, but still we have to take steps so that we can optimize this and use as a energy resource. So you might have seen like many of the vehicles are also coming up, like hydrogen fueled vehicles, automobiles, like they're coming up. Automobile industry is also working towards this. Hydrogen cells, they call it as it is like a battery. They use it like a fuel cell, like other cells. Even hydrogen is used as one such fuel to run the automobiles. So it's in the nascent stage yet. Still developments are taking place.
Yes, sir. Yes, sir. That's all.
Yes.
Thank you.
Thank you, Paul. Okay, over to Haripriya. Haripriya. Okay, Paul, thank you so much for spending your valuable time with our faculty members and students. Okay, I think you were explaining very nice manner. So for the importance of how to optimize the decarbonization and how we are going to use the methods. So I think it is wonderful. So we hope in future also we are going to conduct some FDPs and other webinars also. Okay, thank you so much for giving your valuable webinar for our students and faculties. Thank you so much, Paul.
Sir, appreciate it for your kind gesture. I also look forward for meeting you all in person so that I can come in person to your campus and talk more about this. Thank you, sir. I appreciate that.
Thank you. Richu sir, we're close, sir. HOD sir. HOD, sir?
Okay, Raju. Okay.
Yes, sir. Yes. Okay, thank you, Paul. Thank you so much.
Thank you. Bye-bye.
Thanks for all. Thanks for our faculty members and thanks for students for attending your valuable time. Thanks so much.